Depending on where you live, the electricity you use could be generated nearby, or it could travel great distances along power lines to get to your home. Most of the electricity we use in Snohomish County is generated at hydroelectric facilities. Hydroelectric means electricity generated using the force of moving water. Hydropower is a renewable energy source because the water needed for this system can be used again and again thanks to the water cycle. The water cycle is the movement of water through the atmosphere and the earth. The water cycle starts with precipitation and moves through surface water around the earth. The water is then evaporated back into the atmosphere and condenses in the clouds. We're lucky here in the Pacific Northwest to have an abundance of this natural resource to power our communities. We use surface water to power our hydroelectric projects, including Woods Creek. The PUD owns and operates the Woods Creek project, a 650 kilowatt run-of-the-river hydropower project located along Woods Creek in Monroe, Washington. On average, it generates enough energy to power 300 homes, but when it's at full capacity, it generates enough for 650. Let's follow the flow of energy through the system and see how it transforms from potential energy to kinetic energy to mechanical energy and then to electrical energy. It all starts at the Diversion Wear, which is a 6-foot-tall structure that diverts a portion of the water from the creek to the intake. The remaining water continues on its natural course through the bypass reach. There's a required minimal flow in the bypass reach, which is always maintained. If water levels are low, generation is shut down to maintain the minimum flow, which is important to provide habitat for fish or aquatic resources that may reside in the bypass reach. The next part of the system is the intake. The intake is an opening that allows the flow of water to continue its journey in the system. It has 2 sets of screens to minimize potential injury to the fish from contact with the facilities. The first is a trash rack to keep out larger debris, and the second is a rotating screen that catches and screens out smaller debris and prevents fish from entering the intake. Engineers and biologists have customized the size of these screens based on water velocity for this specific project. The screens are sized so that water is managed and distributed to reduce velocities at the screen and minimize the potential for fish to be impinged onto the screen. At the desired velocities, the fish are able to swim away from the screen and not get injured, while allowing enough water to pass through the screens for generation. The intake is connected to the Penstock, which is the pipeline that takes water to the Powerhouse. The Penstock consists of a 250-foot-long concrete pipe. The start of the Penstock is buried and runs under the existing house structures. Across from the Penstock is a beautiful waterfall that's nearly 60 feet tall. This waterfall is a natural barrier to upstream migration. Near the base of the waterfall is the Powerhouse. The Powerhouse contains the turbine and generator units. Did you notice that the Penstock was angled downhill? After the water makes its trip down the hill, the force of the water spins 1 or 2 of the turbines. The amount of energy in the water is determined by the difference in height between the intake, the turbine, and the quantity of water flowing through the Penstock. Gravity is the only force moving the turbines. The greater the difference in height between the intake and the Powerhouse, the greater the energy the water will possess. The turbines are connected to a shaft which spins a generator. A generator has 2 parts, coils of wire and magnets. Together, they make electricity by transforming mechanical energy into electrical energy. The advantage of having 2 generators is that we're able to utilize a wider range of water flows to efficiently generate energy. After the energy is created, it needs to be transported. We do this using a distribution line. A 12 kV distribution line extends from the Powerhouse and ties into our power grid, bringing electricity to our customers. The line is designed to protect raptors and bald eagles from electrocution. While electricity is one output of the system, water is another. After traveling through the Powerhouse, water is returned to Woods Creek via the tail race. Within the tail race is a rack to prevent adult salmonids, who are attracted to the flow of water, from entering the Powerhouse. The water combines with the water from the bypass reach to continue its journey downstream in the water cycle. Since we acquired this project in 2008, we've conducted multiple efficiency upgrades that tripled the original output. This efficiency increase qualified this project as an Initiative 937 eligible renewable resource. This system is regulated by the Federal Energy Regulatory Commission, but we also comply with the Department of Ecology, Department of Fish and Wildlife, and Snohomish County for environmental resource protection. We're proud to say that our Woods Creek project is renewable, reliable, and environmentally responsible.